Hello, my name is Hannah Lewis, and today I'm going to be going over Lab 2, Lines of Charge. To introduce the concepts that we'll be going over in this experiment, first we will be talking about electric charge and the difference between distributed charge as well as a point charge. Also, Coulomb's law will be covered, law of attraction, and Newton's second law. As well, the purpose of the experiment is to compare and advance a point charge model into a charge distribution model to allow for a more accurate charge calculation. The results of the experiment show that the point charge model gives us a charge of 9.8 e to the negative coulombs compared to the distributed charge model of 2.33 e to the negative 8 coulombs. Some more background on this experiment is that a point charge is when you're using a singular point on an object in order to determine the electric charge overall for the object. Distributed charge is when you would use multiple different points that fill in the entire shape of the object in order to calculate the electric force from all of those point charges summed together. Coulomb's law is then used in order to identify the force of each of those points, and that is going to give us the force value overall when all of them are summed together. We also know the law of attraction, which is that positive and negative charges attract, while like charges will always repel. We also know that Newton's second law means that whenever an object is not moving, that means the sum of the forces acting upon the object is zero. That means we know our floating tape is going to have equal and opposite charges acting on it because it is standing still. A couple assumptions were used in this experiment, including first that there was no air resistance in the experiment, and also that the tapes have equal charges because they were both created the same exact way. The way that these tapes were made was first by taking one tape, placing it on a table, and then ripping another tape off of the top of it in order to charge it. This is how we made the two U-tapes. Then we placed one below the other, like seen in this diagram, and then the distance between the original tape location and the new tape location for tape B was measured. When this experiment was completed in Lab 1, we used a point charge in order to calculate the charge of the tapes. When we did this, we first calculated the force of gravity, and then we calculated the fact that the force of the charge was going to be equal to the opposite of the force of gravity, which gave us that same value but in the opposite way. So then we also measured the distance between the tapes, which is 0.021 meters, and we were able to put these values into Coulomb's law in order to calculate the charge being 9.8 e to the 9 negative coulombs. When this Q value was placed into the distributed charge model, we could see that the electric force was significantly smaller than the gravitational force. This is demonstrated by the fact that the yellow arrow is significantly larger than the white arrow. In order to find a more accurate Q value within this model, the plug and chug method was used to find a new Q that would give a similar electric and gravitational force. As you can see, using Q equals 2.33 e to the negative 8 coulombs gives us 1.96 e to the negative 3 for both the electric force and the gravitational force. This is accurate because we know that because of Newton's second law, these two forces need to be equal. To give you more background on the model that was used, first you can look at the code on the left, which is the values in the electric field function that was created in Lab 1. On the picture to the right, you can see the line charge function that was then used in order to show that there were multiple different points along the total function. Next in the code, the force values and scales were created, followed by the force calculations from one tape to another. This is very similar to what was done in Lab 1 as well, just using that distributed force instead of using a point source. Then finally, the arrows and the print statements were created using the values that were created above. The first conclusion question that we can go over is, what if we had modeled each of your tapes as a single point charge like in the previous lab? Well, this is what we had done, and we found that the charge value originally was 9.6 e to the negative 9, which was compared to our new Q value of 2.33 e to the negative 8. Now, the difference between these two is the fact that Q is 2.38 times larger than the original Q value. This shows that they are obviously very different. But the reason why they are different and knowing which one is more accurate is also very important. Now, the reason we know the new Q value is more accurate is because in any piece of tape there are going to be multiple points within it. And so having multiple points in our model and knowing that's more similar to our tape means that we are getting a more accurate model of what the tape is actually doing in real life. That means that our Q of 2.33 e to the negative 9 is more accurate and is what should be used in the future.